Hello, everyone. Please pause, mute your microphone. All right, let's get started. So today we're going to continue our discussion of MapReduce. You remember we started that topic last week, so we'll wrap it up today. Remember, this is related to your one of your term projects at the end of the semester. So we'll talk about that on Thursday, the Hadoop project a little bit, right? And you should definitely start working on that. So on Thursday, remind me to ask you to form your groups, groups of 2, I think. So remind me about that. And we'll talk about project A and project B, right? So that you guys can get going with all of that. All right. And then you'll have, a simple homework assignment related to what we're going to do today. Okay. So if you remember last week, and I think I'm all ready to go here. If you remember last week, we were talking about MapReduce, and we talked about Hadoop. So we can go to the here, right space, and go to content. And then in here, we were discussing this Hadoop. So basically, I'll just go over these. Probably need to download this. I'll do a quick overview. So if you remember, we talked about cluster architectures. We talked about how MapReduce is the framework, and then Hadoop is the implementation, right? So you probably remember that. And then we talked about the differences between single node and, and then creating parallel systems, distributed systems, basically. Okay. So we talked about cluster architecture, and this is the goal of your project, is to create a cluster of at least 2 machines to be used. So we talked about the problems with implementing such a system, like basically nodes can fail, the network bottleneck, and distributed programming is hard, right? So if you remember, we did all of this. Today, the focus will be on distributed programming. It's hard, right? So we're going to think of that example that I started, and then we're going to try to implement it in code. So I'll provide a solution for it. We'll also look at how we can use the terminal a little bit more to pipe information through it to solve this problem. So there is that additional component to it. And then finally, I'll give you a homework assignment, which will be pretty easy, just kind of implementing. So basically, you will be solving the same problem that you will have to solve with Hadoop, counting some words, etc. But you're just going to do it without Hadoop. So I'm going to show you that in this homework assignment that you can just do it on the terminal. Obviously, the disadvantage to that is that you can't handle massive amounts of data, right? So that's the difference. So, but the algorithm should still work on just, we're going to take some books from the Gutenberg library, some, text files in UTF-8 format. And so, yeah, that's basically how we're going to wrap up the week. As you know, next week is spring break. Also, we'll have our second exam sometime in April. Okay, so just be aware of that. I need to schedule it during a specific week, right, to do some traveling. So we'll do that. Okay, so the exam may not be exactly on week 12. Okay, might be a little bit late, but we'll see. All right, yeah, so that's the plan. As I said, distributed programming. So we talked about the rules, that can happen with MapReduce. The file system, remember I talked about HDFS. The file system is something you will have to deal with on the project, okay? That's something that you have to deal with. So we talked about all of this as well. It's a virtual file system called the Hadoop distributed file system, or distributed file systems in general. We talked about this as well. And then, we talked about how a document, this is an, excuse me, an entire document, and it's going to be divided into chunks, and then each chunk gets sent to an individual computer. So therefore, we need to create key value pairs, right? That's the key thing. And that's something that we're going to do today in our code. We're going to implement that. It should be very interesting. Remember that you're going to have to solve this problem considering parallel computing. Okay, so that's the difference. You still use a lot of the same. It's not like I'm going to introduce like another type of for loop. You know what I mean? It's still the same constructs that you have in regular programming, but you are going to be doing things a little bit differently. Okay, so we talked about this. So this was basically, the MapReduce example that we're motivating. So here we have a document txt, and we need to basically, the steps are to map it, which means we need to scan the input file, one record at a time, extract something you care about from each record. And this sentence actually, which sounds pretty generic, is extremely important. And it's probably going to be the complexity in any problem that you handle. Because counting words is one thing, but there are other problems, right? And so you will need to extract something that you care about for your problem and create key value pairs. Then you're going to sort, as we saw in the last example. And then if you remember, you're going to reduce the results. Does this make sense? So this was the algorithm. So I'm just reminding you because we're going to implement it, right? And so I want it to be fresh in your minds. Remember that we did something like this. We create the keys and the values. After sorting them, we have key 1, key 1, key 2, key 2, key 2, key 3, key 3, and whatever. And so they are sorted, and then that makes the implementation of our algorithm very efficient. Okay, instead of making millions of passes through a list of values because they're sorted, you only make one, and that considerably saves you time, right? So that's basically the point that I want you guys to take away from this. So we did this, the crew of the space ship, right? And so basically we did something where we have to map first, sort. After sorting, we aggregate, okay? And so you can see the pipeline here. This is actually, this is the data. So cat data, pipe into mapper. Okay, so that would have been good to have told me. Sorry about that, guys. Can you see the slide, the slides now? These slides are on Brightspace, but yeah. All right, yeah, so these are the slides. So, sorry about that. Anyway, so as I was saying, this is the problem that you will implement both in the homework on Thursday and in the term project at the end of the semester. The difference being, here we're just going to do it in this pipeline in Python on the terminal in Linux with the CPU and only one machine, right? Not really in parallel. But then later you'll have to implement this in Hadoop itself. So Hadoop actually supports you using multiple languages. So you could use other languages beyond Python, like Java, and so on and so forth. And I think that's probably the last one. That's the last one. So now let's go back. So that's kind of an overview of the algorithm from last week. Let's go back to Brightspace now over here. So we covered this one. And then let's take a look at this one. Then we'll implement this on the virtual machine soon. So here we have, you know, we're going to code in parallel. So we're going to have to create 2 scripts. That's the other thing, right? So it's 2 scripts that, you know, they're kind of independent. They take in inputs, produce outputs, and then we're going to redirect to the next step. We're going to count the frequency of words in a set of books, such as the Gutenberg. Although I'll do a simple example without Gutenberg, and then I will leave Gutenberg to you guys to figure out. Okay. What I want you to do is I want you to realize that the thing that I want you to realize, right, is that I only want you to write 2 Python scripts, map and reduce. You see that? Everything else you need to do in the terminal. You understand what I mean by that? Pure Linux commands. Because that's what I kind of, although I've been emphasizing a lot of scripting all semester, I also want to stress the fact that the Linux terminal is not just for typing ls-l. The Linux terminal is actually a tool. You see that? It's a tool, and you could almost say it's its own coding or scripting tool if you know how to use it effectively. Okay, and that's kind of what this week is about. Is putting that idea in your minds of everything that you can do just by redirecting a type. Okay, and you can also combine some scripts, of course. So that's definitely doable. All right, so and also before I forget, is that it's actually the fastest. The Linux kernel, anything implemented in the Linux kernel or at the level of Linux is extremely fast. So it's gonna be the fastest of anything. You have to invoke a Python script, it is way slower than running it, you know, running the native Linux commands. Okay. So anyway, your homework assignment for this, let me check. Your homework assignment for this week, and I guess for the spring break, will be to download some books from Gutenberg. All right, and then you would run it basically on the cluster, although you're not using the cluster this time around, but the distributed programming scheme or framework is still the same. Okay, that's still very much the same. So this, as I wrote here, this is the problem to solve in this lab. So how are we going to do it? So this would basically be how you would do it. As I said, I'll do a demo and I need to provide these scripts for you. So today and maybe on Thursday, you know, I'll provide all the code. Mapper is actually pretty straightforward. It's very easy and it's short and easy to understand. Reducer may be a little bit more tricky to understand, but not so much. So this is basically the solution to your problem. This is your pipeline. You will cat Hamlet, but actually, you know, like Hamlet.txt that you got from Gutenberg, you can actually cat several documents too. You don't have to merge. Do you have a question? Oh, you don't have to merge them. So let's say that I just, you know, casually said, yeah, download 17 files, merge them and do the processing. You might think by that I mean write a script that goes through all the files and then creates a thing, right? A new file. And you'd spend a lot of time doing that versus you just cat 16 files all at once. And it kind of does the same thing. You guys see that? You see what I'm saying? So it's very important that, oh yeah, go ahead. Huh? Why? Why would? But for what? You mean like downloading different Gutenberg books at every hour, every 2 hours, and then processing? Well, actually, you have an interesting point in the. I don't want you to do it. But you have an interesting point, actually. Let's say that I didn't say download Gutenberg, but instead I said, get a Twitter API or get a Bing or DuckDuckGo API, right? And go to those Bing, Twitter, and download tweets or download images. If I asked you to do that, if you do it all at once, it's not gonna, they're gonna block you because they throttle you. But cron is a good solution for that problem because you, exactly, you download a set of documents, you know, every hour or so, and that way you don't get throttled. You see that? So your point actually would make sense for that, but for this, you don't need to. Okay. All right. So anyway, the solution to your problem will be to cat the files or some, you know, get the files, pipe them into Mapper. Mapper will do the mapping function. Pipe that into a sort function such as this, built in into Linux, into the terminal, then pipe that into Reduce, right? And then get the results that you need. Okay. So I just want to stress, I'm giving you here the solution, right? So this is all you have to do. Okay. Now we're going to talk about the example. So we have a file doc.txt or just a small a sentence. I'll probably just start with a sentence. We're going to have to map, which means we're going to scan the input file one record at a time, extract something you care about, and convert it into key value pairs, which will look like this. Okay. Then we're going to group by key, sort and shuffle, and then we're going to reduce, which in this case will be to add them up. And then we can print out the results. You could use awk just to give it a nice presentation. So the map function will look like this. So we'll write the code in a second. But the map function should look like this. So if you notice, it's a function in Python. It takes in an input. The value is text of the document itself. Then for each word in the document, we're going to create basically a, excuse me, a word and the number one, basically. So we create the key value pairs, the one, car one, is one, blue one. Okay, so that's the process. So here is the mapper function more in a Python-y way. Okay, we can test it just by running initially cat and mapper. You don't have to do the whole pipeline. So here we're going to import sys, and sys is basically so that we can interact with whatever we're redirecting. So if you notice here, the document is being piped into mapper, right? And so this document that's being piped into mapper, mapper uses the sys object. And then if you notice, it uses something called standard in. You guys see this here? Sys.standardin, you can think of that as the input that you receive from pipe. Some kind of a list, something, an iterable object. And so now you can do for-line in sys standard in, right? And then you're going to iterate through it, okay? And then here after that, you just take the input, every line basically. In this case, the story, Hamlet.txt, and we're going to strip and split, right? And that just strip just means removing trailing spaces, and then splitting means split on space because we need the words, right? And then after we do that, words becomes a list, and so forward in words, and we print it out. So this is kind of pseudocode, but it's very Python-y. If you notice here, I print out a string, which is word one. What is this symbol here? You got anyone know what this symbol is? So \T. Huh? The tab, right? The tab. So the tab is usually used as a separator when you're creating strings, right? It's a very good one because you don't use it for other letters. So it's a good character. All right, and that's it. This is mapper. I mean, it's not meant to be very different, right? But This hopefully, my goal is that you at least have a working example of how to solve a problem for parallel computing, in particular for cluster computing, okay? Because you really need to understand that, you know, if you're going to be talking about cluster computing, building the thing is pretty challenging, as you will see in the project. And I'll talk about that in a second also. And then also there's the issue of, okay, you built it, but does it work? So you have to test it, right? So you have to run, and I've given you here the most basic problem that I can give you, right? Count words in parallel. Any questions about Mapper? Pretty easy, right? Okay. Then reduce, as you can see, this one's a little bit more challenging. This one I'll discuss basically in the code itself. But just here in an overview, you can see we have import sys. We initialize some variables, current word, because you know they're all now. Remember, this code assumes that we've already sorted the key value pairs. This is very important, right? So we have the cat. So whenever you have a transition between one word and a new word, you need to take that into account, right? So that's why you have current word none and current count 0 and the current word or the word itself none, right? So you keep track of that transition basically by doing this. For line in standard insist standard in, remember this is the input that you're getting from the terminal itself. So we get the line, we strip it, we split it on tab because that's how we organize them, right? In the previous one, we are using the tab as a separator. Okay, so that's the idea. Anyway, and so we get word and count, which this is always a 1. This is the actual word. Then we use a try catch. I think I've introduced this structure before for the networking examples that we did at some point. And we count, right? So we're going to count. Basically here, we just take the count in here, and because it's a string, we make it into an integer. And then if we have some kind of an error, we just keep going. Like we disregard that word for whatever reason, drop it. You know, out of a million words, if you have that, you know, it's sometimes you might have a problem in what you're processing, but it's only like 7 cases out of a billion. Is it worth writing very complex code to deal with those 7 cases out of a billion? Or is it just better to just, you know, consider it noise or whatever? So that's kind of what's happening here. And then here, then, if it's still the current word, so the word that you're looking, if it's still the, then just increment the count. If not, if there's a transition, then emit the new word, right? So you're going to emit the current count, current word with tabs, and then you reinitialize the count to 0. You reinitialize the words to the new word. And then this little thing here is because whenever you do these kinds of things, there's always 1 at the end that you didn't print. And so this just prints the last one. You'll see that if we don't do this, the way the logic works, we've left this, you know, left this one out. So these are off by 1 errors. They're common. I was actually working on something recently and I had the exact same issue. I was leaving something out. So they're tricky. Anyway, so yeah, and that's it. So then the problem that I'm going to do today, now this example, when you've set up Hadoop, you can test it in Hadoop as well. We'll use the Hadoop in the future in your project. You will use the Hadoop streaming API and everything. For our purposes here, we will have to make the mapper and reducer executable. And then I'm going to give you an input such as this one. And then you'll be, you'll get this, right? In the mapper output. And then after that, when you do the final example, the reducer, you will get this, which is the count. Okay, and that's it. I mean, that will conclude our discussion for this semester of cluster computing and MapReduce. Hopefully this is good enough to get you going. As I said, if you have an interest in parallel computing, building like whole semester, take 470 with Professor Kim. It should be a pretty fun class. All right. So that's basically the that example. So let's go ahead and start the virtual machine at this time. I'm going to go over here. Oh, I have one more thing. Hold on. So let's go back to the Brightspace. So we're back on Brightspace. If you click on this link, Hadoop, see, it takes you here. Okay. So I've provided a couple of things. This is the homework, basically, that you will have this week. Download at least 2 books from the Gutenberg library and calculate the frequency of all words in these books using the provided mapper and reducer functions, which I will give you in a second. The other thing is I provided these 2 links, right? And I guess I wasn't sure where to provide these. So this place is fine, I guess. These are just, they're not tutorials. Again, I stress this, right? These are not tutorials, but they are a starting point for your term project. Okay, remember that the VM that you select, that like if you select 2004 or 1804 or whatever you select, that's you need information for that specific distribution of Linux. Otherwise, you're gonna be very sad if you follow this to configure another model VM. But this is a good starting point to start reading about Hadoop itself specifically. So these links talk about single node configuration. Pay attention to this, what I'm saying here, because this is actually really important. When you start your project, which I think I said groups of 2, right? Groups of 2. Make sure you start thinking about who you're going to work with. My suggestion is start here. Configure the single node first. Okay, it's the easiest to configure because you only have one machine. It's still implementing Hadoop in parallel just on one machine. At the end of the day, Hadoop doesn't care if it's one machine or 30 or 1,000 machines, right? It just creates a framework for distributing the data in whatever you give it. You know, whatever you decide to be the Hadoop distributed file system. But anyway, start here with the single node configuration, then do the multi-node, right, configuration. And then you can see here, there's some additional examples about doing Python scripts and a few additional commands. So if we take a look at the first one, you can see here running Hadoop on Ubuntu Linux single node. This has got some nice information about Hadoop itself. As I said, it's not a tutorial, but it's just a starting point for your project. Read through it, as it'll give you. What I would suggest is read through it first. Don't like start to just type commands on the Linux terminal. You have between now and the end of the semester, right? So you have a good 8 weeks probably, right? Because you're gonna present this like at the last week before finals. But notice here, in essence, you'll have to install, first of all, some with apt, you're gonna have to install some dependencies, including Java. You need to look at the Java version. Notice that you're gonna be creating groups and users. Remember that I talked about this, right? One of your previous labs that showed you how to do users and groups. Well, now you have to create these. You're gonna have to use SSH and configure keys, public and private keys for the secure communication between the instances, right? So you're going to have to set some environment variables. Okay, make the connections and test them, disable some features. And that's just to get started, right? That's just to get started. Then after that, you're going to start with the configuration of Hadoop. So you have to find the Hadoop. Are you going to install it from source, right? You have to think about all these things, right? Okay, you have to change the ownership, move it to specific locations. make sure that you have good mappings in your profile file of things that you're going to be doing. And then here it starts to talk about the Hadoop distributed file system. Okay, and then, you know, it's pretty much what we've talked about in the semester. Then you start to do the configuration and updating files. Okay, so you have to update some files in here. Okay, and notice, remember the Linux philosophy, right? Everything is a file in Linux, and when you do your configuration in Linux, you have to go in. You have to go in and look at your text files and configure parameters. So this is XML format. Then after you've configured things and it starts to talk about the commands, notice that you start calling Hadoop itself, and then Hadoop as a thing that you would call in the terminal has specific flags and commands, right? And you're going to start up the Hadoop service. So how to start the service. So have some commands. What happens, this JPS command is one of the things that I will use to check when you've done your implementation. So you'll show me you'll have two machines, let's say the cluster, right? And I'll go to both and type JPS and nothing will appear here. Then I'll say, okay, now go to the main computer, start the cluster. You're going to start it. How am I going to know that you did it correctly? I will go to both machines, type JPS, and now certain processes are going to appear there. Do you guys see that? This is how I will know what's going on. Does that make sense? All right, so make sure, but as I said, do not go by this as a tutorial. Read through it, okay? Read through it and just try to understand. Notice here, you know, you're a lot of the commands, you know, using grep to check some files. Okay, starting and stopping services, and then running a MapReduce job. You can see here pretty much the same theme. Grab something from the Gutenberg library, a couple of stories, the notebooks of Leonardo da Vinci, etc. And then notice here, you create a local folder, right, for your books. You start the Hadoop cluster over here, and then now you copy local example data to the HDFS. Do you guys remember I said that? So you're going to copy your files from the local physical hard drive to the Hadoop distributed file system. Keep in mind, once they're loaded on there, you can't just use regular Linux commands and find your files. You're not going to find them because it's a virtual thing. The only way to like reach them is going to be through the Hadoop interface for the HDFS. Does that make sense? Any questions? Pretty easy, right? And so, yeah, so you will, you know, follow, you know, these are some of the commands, but as I said, you have to kind of get a feel for it. Here's an example of how to run the built-in programs. Like there is a program called word count. Okay. And then the jobs run, and then you can visualize the jobs, and then you start getting your output. And then this output that you see here is what I will be looking for. Okay, this is one of the, like in your report, this is the screenshot. And when you do your demo at the end of the semester in your cluster, I need to see this, which basically means you did the count of the words correctly. And here they are. Got it? All right, so that's an important one. Now, Hadoop has some web interfaces. So what that means is that when you start up Hadoop, you will start some GUI, some web pages, basically, that provide information. So you will use some of these to just see the status, right? So you'll look at, you know, the Hadoop cluster has been started up. And then this is the job tracker, and you can see the jobs that are currently running, memory utilization, etc. Okay. And then you have this. Okay. And so that's kind of for the single node, right? Single node. Then the multi-node, right? You can read through this one. It explains a little bit of everything. It's got the commands, etc. So make sure you go through that as well. And then if we scroll all the way down, we will have the Python scripts. So this is what I will focus on today. right? So these are that's the mapper function. This is the reducer function. So you can just get this code that I'm discussing today, you can just get it from the third of the 4 links that I provided, okay? But I'll explain this, then it shows you how to test your code by piping, as I said. This will be the example that we're gonna do. Everything is there. And yeah, so that's, and then these are the commands if you were running this in Hadoop itself with the Python script. So notice here, this assumes you've already set up Hadoop, right? And now you would notice here, you're invoking mapper and reducer PY from Hadoop itself, and you'll be doing the job in parallel. Does this make sense? This part here? Okay. Now, of course, you know, the example that I'm going to do will not use Hadoop, but I'll just demo the code that it does work, right? And then at the end of the semester, when you guys have set up your Hadoop cluster, you can run these scripts again. It'll run just like this. It's sent, basically, you can think of this as the code is being sent out to all the nodes in your cluster. And so it'll be, you know, those 2 scripts are in every node, and they'll be able to process the chunk of data that they have, and then Hadoop will be able to aggregate it at the end. Okay, you can take a look, as I said, at the GUIs, provide information, and then at the end of the day, you get this, which is the tally of, you know, the number of words that you found in the example. Okay. Okay, and so that's basically the idea. Are there any questions? So today we talked about we talked about MapReduce, just did a review of that. And then after that, we talked a little bit about Hadoop itself, these links. And now all that's left is for me to go over the scripts, do the demo, and then you will just repeat this exercise with actual Gutenberg files. So it should be very easy to do. Okay, so let's go ahead. So I assume you understand. I'm not hearing any questions. So I'm gonna start up the virtual machine. Let me go ahead and start the VM. So we've covered in the folder Hadoop, we've covered all the files now, both slides and this document. Remember, this is the assignment. I'm going to create the assignment already so I don't forget. So this will be due actually, hold on. I'm just going to copy this problem. So this is just going to be MapReduce coding. Okay. Today, this will be due on the 24th, okay, after spring break. So download at least 2 books from the Gutenberg library and calculate the frequency of all words in these books using the provided mapper and reducer functions. I think that should be clear enough. So this will be open now, and it'll stay open until Saturday the 26th. All right, so that link is already created. All right. So if you go to table of contents, Hadoop is done. So we're done with this folder. And now let's just go to the so let's go to the virtual machine. Start it up. Right, so I'm going to share this screen. All right, so we are going to start up. So everyone should be seeing the VM now. So let's give it a minute to load up. All right. Now we can open up a terminal. QLS, navigate to the desktop. And this is 372. I'm going to minimize this a little bit. Okay. Okay. So we're going to need to create a couple of scripts here, right? Let's start with mapper. Mapper should be the easiest function to implement. Start with mapper. Should be the easiest one. All right, so let's go ahead and create it. So I'm going to call nano mapper.py. Okay, we're going to add the path so that because this is going to have to be an executable so that we can run it on the terminal. So we need to know what we're using or where to find our environment. So we're going to do import sys and then for line in sys.standard. Okay, so for line in sys.standard in. Okay, 1, 2, 3, 4. Now we're going to remove trailing spaces. 4. So that's going to be line. So that's going to be line. We assign to it the same line, but we're going to strip trailing spaces. Okay. Then we're going to create a list called words. And that's going to be line.split. We're going to split on, basically by default, it'll split on space. You could also just make sure you add a space in there. Right. Okay, and then that basically takes in whatever input we give it, right? And it's going to split it up into all the words in that text, basically, so that we can iterate through each one of those words. So now I'm going to do for word in words, and then 1, 2, 3, 4, 1, 2, 3, 4. Okay, and then now we are going to emit basically the key value pair. So this is the mapping process for this particular problem. So we go down here and it's going to be print And then we just have to decide what we're going to print here. So let's try this approach. So percentage S tab percentage S. And then the inputs we can provide in a tuple basically. So it's going to be the word and the number 1 because every single one is an instance. Okay, and once we've done this, we should be able to run this program. Are there any questions about this script? Pretty easy and clear. All right, so I'm going to do Control X, Y. Now I'm going to go ahead and make it executable. So I'm going to chmod plus X mapper .py. Okay, /L. So the mapper.py is right here. Notice it's executable for everyone. So now it needs an input. So the way that we're going to run it is I'm going to cat something. I'm going to cat an input. So what can I do? So the cat is sleeping on the bed. Okay. On the bed. And then I'm going to pipe this. Oops. I'm going to pipe. I'm going to pipe this into the executable function mapper. Okay. So I'm going to have to do that. Okay. So let's do mapper.py. All right, so it says no such file or directory on the bed. You guys see an error? Python 3, thank you. Oh, yeah, but it's executable. So Python 3, you mean in the file itself, probably. So you could go over here and then Python 3. Control. Let me try, let me just do this for now. What is it? No, it's not it shouldn't be this part. This should work. Oh. That part's not working. Yeah, that's the thing that's doing an error. Okay. Oh, okay. Yeah. Yeah. You know what it is? It's not cat because it's not a file. You're right. Good catch. Echo. There we go. Good. All right. So now let's try this one again. Not with cat, but with echo. And there you go. See now. Make sense, guys? Clear? Pretty easy, right? All right, so we've completed that part. That's the mapper function. It takes all the inputs. The cat is sleeping on the bed. Notice the becomes a key value pair. This other the becomes a key value pair, so they all become key value pairs. Okay? So now the next step is to do the reducer part, right? So the reducer part is a little bit tricky, but for the reducer part to work, we also need to sort it first, right? So we need to sort our data. So in that case, we need to try some things. We're gonna play with this a little. So now I'm gonna do echo, and after mapper, I'm going to once again pipe it, right? Because these, so notice here, they are not sorted. You have a the down here, up here, and then another the down here. You want these to be sorted. So you could say, I'm going to write, you're going to go to your data structures class and you're going to write the code in Python and everything. Or you can just use the terminal's built-in commands. Okay, so just pipe it in. And then there should be a sort command. So we need to find it. So let's try. See, this one worked, but it didn't, but it's sorted in a specific way, right? So you can see there, bed, cat is on sleeping, and the are now sorted together. Questions? Yeah, go ahead, please. Huh? The mapper? Sure. There it is. Got it? Great. Yep, no problem. All right, so now the next step, so we've got the mapping function done. Now we're going to proceed and create the reducer function, which will take the output. So now the pipeline is completed until this point, and then now we need to do reducer.py. Okay, we don't have this yet, so this script we do have to implement, assuming that our data is already sorted. Okay, so we're going to go ahead and create reducer.py. Okay, and we're going to do the exact same thing. So we're going to do user bin environment, and it's going to be Python. Okay, so now we need a couple of things. We're going to import sys. Okay, we need import sys. We're going to initialize a couple of variables, as I explained before. So we're going to initialize current word, which will be set to none. That just means it's pointing to like a null value. Current count, which will be initialized to 0. Okay. And word, which will be initialized to none as well. Okay. So this is the way you want to proceed here. So now remember, we're going to have to do the for loop that takes in the standard in, and then we just have to account for the last word at the very end. So I'm going to do for line in. Remember, this is now the data that's coming in from the pipe. The pipe from sort, from sort we pipe into here. So this is going to be sys dot standard in. Okay, and now we do 1, 2, 3, 4. Okay. We do 1, 2, 3, 4 here. And now again, we take in the line dot strip, line dot strip. Okay. And now we can split the line, but this time around, we're going to split it on tab. Okay, and by splitting it on tab, it's actually going to return two values, the word and the count, which is usually 1, or always 1. So I'm going to say line dot split, and then I'm going to split on tab, one value basically. So now let's just go ahead and print word comma count so we can see what happens. So this should print out. Now we can put in an input here just so that we can look at every single entry one at a time. So this will run the entire pipeline. Oh, and also we need to make it chmod. So chmod reducer .view. Okay, so we've now made it executable. We've got mapper and reducer there. And now we can go ahead and complete the pipeline. It's not done yet, but I'm just testing it. So now we can run it, and it gives it error. That's an interesting one. You know what I'm going to do? I'm going to add the try, because the try may take care of this. No, actually, what's the issue? Line 13. Oh, it's the input. Yeah, that kind of makes sense. I'm gonna remove the input. Let's see. Yeah, all right. Good. So now it should work, right? It's not doing anything really. The reducer, we didn't redirect its output. Okay, so the reducer, we take in the input and we just print word and count. Let's keep going. Maybe I'll spot the issues. So here, this print statement we don't actually need. I'm going to take that out. Here I split the word and the count. I assume that would work fine. Then we're going to convert count from a string to an integer. So int count Then here, so let me try that. Make sure it doesn't error out. And now because it's sorted now, we're going to check if there's a transition. So I'm going to do if current word equal word equal word 1, 2, 3, 4. Then current word equals current word plus 1. Plus actually plus count. Count is 1, but okay. Else they're not the same. It's a transition. 1, 2, 3, 4. And now we just check if current word exists. So if current word one, 2, 3, 4, we're going to print out the total. So this should be, we did before, percentage S tab percentage S, and then we pass to it current word and current count. Comma. We pass these two. And then we reset these variables to be the current word and the current count. So that would happen in the if statement as well. So current count is going to be count. Current word is going to be, so let's see if this works. I thought we made that into an int. Current word is a number. Let's do a try catch just in case there's an issue there somewhere. Try 1, 2, 3, 4 this one. Four else 1, 2, 3, 4. Oh, sorry, not else. Except value error. And let's just say continue. So if there's an error, just continue. So 1, 2, 3, 4. Let's try that. Otherwise, there's some bug that I cannot see. Current word equal current word plus count. Can only concatenate string, not int. So, oh, wait a minute. Yeah, this should be current count, not current word. Sorry. Okay, let's try it again. Did it work? No. Let's try that one. See, it did work. You guys see that? Did it map and then reduce? Or no? Sure, I'll go to the code in a second. Let's see the word the appears. The cat is sleeping on the and on the, and there's another cat. So there's 3 thes. There they are. Cat, there's 2 cats. There they are. Is, there are 2 is. There they are. Sleep, sleeping. There's only 1. There it is. On, there are 2 ons, on the bed and on the pillow. There are 2 ons. The, we already said there's 3. Bed, there's 1. And, there are 2 ands. And on, there's 2. The, there's 3. Pillow, there's only 1. And there's 2. There, how many there's? The cat is sleeping on the bed and on the pillow, and there is another cat. So there. There is not here. Do you guys see that? But if you notice, TH goes after, there goes after the. It's probably the last term. And this is what I had said. The way this code works, it kind of does not print out the last one. So we have to do that. So we'll do that in a second. Is has 2. There's this is. Another is only 1. And cat is, there's 2 cats. Okay, so now we need to go back to the script, change the reducer function a little bit more. So let's say output last word. And so here we just say if current word equal word. If current word equal word 1, 2, 3, 4. We're going to print out, we're going to emit basically the last one, very much like we did before. You know, the format string, so percentage %s have, oops, that's not percentage %s tab percentage %s, and then we plug in there equal 2 format strings, this one and that one, which are going to be current word and current count. Current word, comma, current count. Does this make sense? So if I do Control X, Y, run the entire pipeline, and then now we have there, and there's only one of them. Let's try another example. We're going to do one intentionally with specific words. So we can echo out foo, foo, q, labs, foo, bar. Oh, bar. And then let's add one more q. So now we run this one, and there we have it. We've got 1 bar, 3 foos, 1 labs, 2 Q. And that's your example. Is this clear for everyone? All right. So that's map and so that's MapReduce. And what's important here to understand is, as I said, this would work both here and on the Hadoop interface. Notice the emphasis on combining up, creating a pipeline literally with pipe and using built-in commands on the terminal. So that's example of how to be very efficient with this. Okay. Next thing you need to do is you need to download some files from Gutenberg. That's your homework assignment. I suggest that you try several files. Okay. So as I was doing before, instead of echo, now you're going to have to do, just going to make up some names here. Let's assume that you downloaded some files, right? So you do hamlet.txt. You can concatenate several files, and that should basically create all the output for you to use. Sort, the sort command can take some flags. So, you know, I encourage you to like play around with the flags, right? So figure out, that's an example of how to add flags to the sort function so you can get multiple functionality. All right, so that's obviously this won't work because I don't have Hamlet, but that would be the approach to follow to obtain. Right, so we've covered basically an example of a pipeline for solving a problem in a cluster computing environment. Now, all right, so before I continue, are there any questions about any of this? Okay, pretty easy. All right, so let's see. So other things that you can do. So I just want to give you another little example of doing this, right? So you actually, the approach that I took was very specific for counting, right? But really, we can use other formats to be able to get solve other problems. So I'm going to go ahead and create, I'm going to take mapper, right, .py. I'm going to copy it into another one. I'm going to call it TF IDF mapper. And this just implies that this would be another technique, right? So I create that. Now I can go to TF IDF underscore mapper.py. All right, so we've got our original script, but now let's say that the problem is not just counting words, right? But you want to find out the number of times a term occurs in a document. You see that? So you basically, your value is not just the overall counts of the or whatever it is. Now you want something a little bit more specific because you want to do some calculations. This is going to be called term frequency. It's just a, you know, it's just another example. Okay, don't worry so much about the technique term frequency, but just think of it intuitively that you want the number of times a term occurs in a document, specific document itself. So you would also want to know the number of documents that contain the word, etc. So you want some parameters, and then you use these parameters to do some kind of a calculation, right? Some kind of a calculation. So the question is, how would we go about doing this? So what we need now is we need more information in the mapping function, right? Because we need to be able to do counts, but we need to do counts that take into account the number of files as well, right? So a way to do this then would be same thing. Let's say that we have we want kind of the same thing as here, right? We're analyzing some files, we're reading in some inputs. So we could map, we don't just need to map two things, we could actually map three things, for instance. So we could do here another tab in another percentage S. So now what we're going to have is we have outputs that will have three things. So for instance, the example, I'm just going to like plug it in here, hard code it, and I'm just going to say file.txt. But you might imagine how we would be able to get some file from the OS, right? So we can put in OS, current file, etc., and plug it in here. But as you can see, what I'm doing here is creating now a mapping that involves more information, okay? And so we can take this approach, right? Now let's try it out. We would need, let's use this one. And the function now will be TF IDF mapper. But without, let's not do the reducer yet because the reducer does not really know. So if you notice here, now we were able to map kind of the same thing really quickly, but we have the, and we have a file, and we have the ones. So if this file was changing, like let's say that we read a file and we read all the words in that file, we put the name of the file, then we read the next file, all the words in that file and the name of the file. Now we will have for every key value pair, right? We've got actually two keys, the word, the name of the file, and the value itself. So now you can see how we can, in the reducer, we can now do calculations taking into account not just the words overall, but the words per document. You guys see that? So that's the idea. So here, just by doing a modification as simple as this one, we are able then to generate inputs that would look like this. So if we go to the whiteboard here, So we would have a mapper. All right, so we would have, the mapper function. Let's say we have a series of documents, right? A whole bunch of documents. And then we've got some logic to iterate through these. So then these documents go through the mapper. Now remember, this is a different mapper because we have a different problem that we want to collect. So this mapper would output here, let's say apple, dog, right? Because we haven't sorted it yet. Tree, I'm just making up tree, but we also have, it's like, instead of being a tuple, it's a triple or a truple. I don't know what to call it. So we've got, this might be file 1, and this is file 1, but this could be file 2, file 1, file 3, for whatever reason. You see that? So it's not that it's always limited to that one key value pair. You can create other orderings, and then this is still the same. So the omission is still that there's one entry, right? You need to create the independent entries that you have here. Then you're going to run this into the sorting mechanism, of course, sort. And then after this would go into the reducer. Here we're going to do reducer.py. And now you can find some specific scheme where you're able to now order things, right? So you might order things by the files, etc. So you might do a count of, let's say, oh yeah, we have dog in file 1 twice, right? So then here we accumulate, and I'm going to need to, actually, I'm going to move to the next page. So here then, you would have the reducer.py. Okay, and so now you have here, let's call this, this should be the count of the words per file. Okay, so this then would give you file 1. So dog, file 1, and it is 2, for instance. You see that? So how do you accomplish this? Obviously, the mapper just creates it like this, right? It creates more parameters for you to process. And you saw that the logic that we did was very similar. Obviously, to be able to tally these up, the code in the reducer is the one that we're going to have to change a little bit. It'll be a little bit more complex, but not really that much. Okay. And so that's really the idea. We would have that apple in file 1 appears, how many times? Just one time, right? So it would be 1. And then we would have, there's another apple, but it's in file 2. and it's just one. And finally, I think it's tree in file 3, and that's just one. Do you see that? So that's all I'm saying is that it's not that it's just that one mechanism that we did for counting. That's more of the logic. You know, it can change, and you can process a lot more information. So the reducer, I don't want to get into this one necessarily. I think you guys can imagine how it would work, I just kind of wanted to convey that idea that obviously to be able to process, to get this output, we would need to take this as input, sort it, split it, right? And then find some logic where we can iterate through all of these, okay, efficiently, basically. We might sort by file, we might sort by words, but you do not want to use for loops here, right? More than one for loop, which is because it's already sorted, so you should be reading. You should be reading oops, like this, then like that, then like that, then like that, then like that, until the end. All right, and that's basically it. So that's the example. Okay, and that concludes our discussion of MapReduce and Hadoop. Okay, so that's basically what this topic. So I hope it makes sense to you. Remember the term project, I want us to work on that on Thursday. So I'm going to dedicate Thursday for you guys to get together, form your groups of 2, right? And then we're going to talk about the topics that you should select. So obviously the term project, I usually divide it into 2 parts, part A and B. A has already been assigned. I would recommend that on Thursday, you already do a little bit of research now, find a couple of VMs, right, that you want to use to configure Hadoop. So I'm going to give you kind of Thursday to get started with that, ask any questions that you might have. But remember, that's one of your semester projects. As I described, start with the single node, then work your way into multi-node. So you need to make decisions on what VMs you need, get the VMs, clone them, etc. Find the distribution of your VM, read through that document that I gave you, those 4 links for Hadoop, then find a tutorial online for the specific distribution of your VM for Hadoop, and then start configuring it. You guys understand? And then that's project A. Project B, we'll talk about that on Thursday as well. And then I think you have a homework assignment due, correct? And that's the attacks DNS, which I gave you the solutions for last week. All right, so any questions, guys? No questions? All right, so yeah, so if you have any questions, just ask, but this kind of concludes the topic. So let me go ahead and stop the recording.